Good morning, students. Today we are going to start with surface chemistry, the fifth unit of chemistry. Now, surface chemistry, it is the branch of chemistry which deals with the phenomenon that occurs on the surface. So, this phenomena is studied with the help of adsorption and colloidal state. So the first phenomenon, which is a surface phenomenon, which we are going to study today, is adsorption. In adsorption, there are two terms you need to understand: adsorbate and adsorbent. Adsorbate is the component which gets adsorbed on the surface. And on which surface it gets adsorbed? That is known as adsorbent. So adsorbent is the component which provides surface for adsorption to take place, whereas adsorbate is the component which gets adsorbed on the surface of adsorbent. So let us suppose that this is the surface on which the phenomenon of adsorption has to take place. So what do you mean? As I said, that adsorption is a surface phenomenon. When will we say that adsorption has taken place? So if this is the surface, this will act as adsorbent. It will act as adsorbent. And on this surface, some molecules or particles, they come and get accumulated. So if this is the surface, then on this surface some particles, they come and they get accumulated. So this accumulation of particles on the surface is known as adsorption. Let us take an example to understand the phenomenon of adsorption. As you are seeing, this is a beaker, and in this beaker, say I have put some ink. As you know that ink has some colored dyes dissolved in water. And in that ink, if a charcoal piece is put, this charcoal piece, it acts as adsorbent. It acts as adsorbent. And what it does, it adsorbs the particles of dye, colored dye, on its surface. So it provides surface for adsorption of the dye molecules, which is a color. So the dye molecules, they get accumulated on the surface of the adsorbent, and here adsorbent, as I said, is charcoal. So this colored dye or ink, it is acting as adsorbate. So accumulation of particles on the surface is known as adsorption. So as a result of adsorption of colored particles by the charcoal, slowly the ink will become colorless when adsorption is complete. Now, what is the reason behind it that adsorption takes place only on the surface? Let us understand. Now, suppose these are the molecules, and they are the molecules of adsorbent, which is providing surface for adsorption. So these molecules taken in a vessel, they are in contact with other molecules in the bulk. So the molecules which are in the bulk, they are surrounded by other particles. So let me suppose, say this is the particle in the bulk. This particle is surrounded by other particles, and hence it is experiencing force from all the sides. Hence, the net force acting on the particle in the bulk, any particle in the bulk, is zero, as equal force of attraction is experienced by the particle in the bulk. But a particle on the surface, say this is the particle on the surface, this particle is not surrounded by any other particle above it. As this is the surface, so all the surface particles, they are surrounded by its own kind of particles only from downward, and upward there is no such particle. Hence, this particle is experiencing force of attraction only towards downward. So all the particles on the surface, they are experiencing a downward pull, and hence there are some residual forces which are acting upon the particles on the surface. Hence the particles on the surface, they act as active sides. So to nullify the force, what they try to do is, whatever particles they are coming in contact with, they try to accumulate those particles on its surface so as to balance this residual force of attraction. So if this is the adsorbent, so particles on the surface of the adsorbent, as you can see, they are experiencing imbalance in the force of attraction, as they are surrounded by other particles of its kind only from the downward. Whereas particle in the bulk is surrounded by particles of its kind from all the sides. So this particle experiences force of attraction equally from all the sides. Whereas the particles on the surface, they do not experience force of attraction from all the sides. There is imbalance in the force of attraction. Hence, these particles on the surface, they have some active sides, and thus in order to satisfy their force of attraction, imbalance in force of attraction, they adsorb some particles of other component on its surface. So that is what is adsorption. Now let us take some examples. This example, as I said, if you put a charcoal piece in a colored dye like ink, charcoal, it absorbs the color components of the ink. So charcoal is acting as adsorbent, whereas the dye or the ink particles are acting as adsorbate. Now some more examples of adsorption let us see. In gas masks, charcoal, activated charcoal is present, and those gas masks which are used by the workers working in the mines, coal mines, or by traffic policemen, it absorbs the poisonous gases. So this activated charcoal, it acts as adsorbent and adsorbs the poisonous gases. So that is one example of adsorption. Another example is adsorption of water by silica gel. Silica gel, which is sodium silicate, it acts as adsorbent and it adsorbs moisture. It adsorbs moisture. You must have seen a small sachet of silica gel. They are placed in the packets of the electronic devices like mobiles or the water cool jugs. So this silica gel sachet adsorbs moisture, that is, the water particles, they get accumulated on the surface of silica gel. So adsorbate, adsorbent, these are the two components of adsorption, and for adsorption to take place, the surface of the adsorbent, they have some active sites, as a result of which the particles of adsorbate get accumulated on its surface. There is one more similar term that is absorption. So though there is only one difference in the spelling of adsorption and absorption, but there is vast difference between the two phenomena. As we just studied, that adsorption is a surface phenomenon, whereas absorption is a bulk phenomenon. So let us understand this by taking an example. Say if this is water, then if a piece of, or if the sachet of silica gel is placed in it, say this is silica gel, then what will happen? And in another container, we are having water in which a crystal of anhydrous calcium chloride is put suspended. Now this is anhydrous calcium chloride. So the phenomenon which takes place in these two containers, silica gel adsorbs water, and hence the water molecules, they accumulate on the surface of silica gel. So this is adsorption of water molecules on the surface of silica gel. But in the second case, where anhydrous calcium chloride is put in water, anhydrous calcium chloride absorbs water. It means the water molecules, they are uniformly distributed within the space of anhydrous calcium chloride. Thus we say that adsorption is a surface phenomenon, whereas absorption is a bulk phenomenon. So this is showing adsorption, whereas this is showing, this is absorption, where calcium chloride is absorbing water, whereas this is adsorption. So this is a surface phenomenon, this is a bulk phenomenon. So water molecules are evenly distributed in the vacant sites of anhydrous calcium chloride. So these are the two main phenomenon, and the difference between absorption and adsorption we have come to know. Next term is sorption. Another term is sorption. Sorption term is used when adsorption and absorption both take place simultaneously. When these two phenomena, adsorption and absorption, both take place simultaneously, then it is known as sorption. Another new term which you are going to know about is desorption. 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 Desorption is opposite of adsorption. I said desorption is opposite of adsorption. So how can we define desorption? The process of removing an adsorbed substance, or the process of removing the adsorbate from the surface of adsorbent, is known as desorption. Adsorption is accumulation of adsorbate molecules on the surface of adsorbent, and desorption is the process of removing adsorbate molecules from the surface of adsorbent.